All right, guys, I had a student who did the homework but said she wasn't 100% confident in her work. So we're going to go over this one, and instead of just sharing it with her, we'll share it with everyone who is watching. So let me see if I can make this a little larger first. All right, perfect. So on this one, we have two angles, and we're missing we're being asked to identify the third angle and the two sides. So we're going to go in order. We're going to verify her answers, and we're going to talk through how she probably got them and how we would get them based off of what we learned in class. The first one, we have a capital B here. And remember, capital letters.
It's all over, boys.
Always equal angles. Lowercase or sides. So let's start by finding the measure of angle B. And we can do that really simply because we have two of the three angles. And I know the inside of the triangle has to add up to 180. So here I'm going to do a little backwards. I'm going to add her 38 here. I'm going to get 88. Two more puts me at 90, plus 90 brings me back up to 180. Obviously, you guys can check it on your own on that one. Probably not the part where we're struggling, but that's 38 degrees right there, and we can see that that's right. Now, here I know I'm looking for a side length, so it's going to be an unknown, obviously. So I'm going to set up that template I told you guys to always set up. This is my left, this is my right. And remember, on my left side, have a known angle and its opposite side. So here, since I'm looking to solve for little b, I'm not going to use these yet because there's an unknown there. Always start with the left-hand side being an angle that you know and an opposite side. And we know the angle always goes with the trigonometric function, and it's always angle over side length. Now, that's something I say to remember, but if you're writing it out in this template, you know the angle, your reference angle always goes with your trig function, so you're not going to have to remember that sine is always in the numerator, or that the angle always goes in the numerator. This is why I really like, and I keep suggesting, we set them up this way. So then the question becomes, what goes on our right-hand side? Well, we need one known piece of information. It's going to say one known info and one unknown info, right? Our unknown is, what are we solving for? And for that, I know I'm looking for side B. So even if I don't have this diagram here, I know my sides go on the bottom, so I'm going to put my variable or my unknown there. And then I'm going to come to side B and see which angle generated it, and that's going to be 38. So from here, we've set up the law of sines, and all we have to do is go through and do our basic algebra steps. Cross multiply, and I'm going to have B times the sine of 50. I'm going to say it again. Oh, that's a heck of a line. That's not what I wanted to say. Sine of 50 is just a number. I can't divide by sine to get the 50 out of those parentheses. The sine of 50 is just like the number 3 or 4 or even pi, more closely to pi. Sine of 50 is probably going to end up being irrational. So just keep that in mind. Sine of 50 is a number. Sine is not like adding where I can undo it with subtraction. I do have a function, the arc sine, that will undo the sine, but that's going to give me some other piece of information. Instead of considering my sides, it's going to tell me what angle generated those side proportions, but we already know the angle, so I'm not going to need to do arc sine here. And now I'm going to cross multiply on this side, and this is going to give me 8 times whatever the number is for the sine of 38. Now I want b isolated, so I'm going to divide by sine of 50. Again, I take the whole argument with me because sine of 50 is the number that we're dividing by. But just like I would rather write 1/3 instead of 0.3333333, I'm going to keep it as the sine of 50. And of course, these cancel, and I'm ultimately left with b is equal to 8 times sine 38 over sine 50. And I'm going to use the computer calculator so you can see how I punch it in, even though it is going to be a bit messy on the screen. Let me pull it up. I am using a Windows computer, and the first thing I want to do whenever I open this is, if I don't have this trigonometry button to get my trigonometric functions, I'm going to come up here, and I'm probably in standard form, right? I just have a basic calculator. Not everything we need to be successful. See if I can make this just a tad bit smaller. No, this is okay. So I'm going to go ahead and change it back to scientific so we can actually answer our questions. And what we have here is we need to get in this right here. So I'm going to do 38. I always start with my trigonometric function because I know I have to press a few extra buttons. So 38 sine. See, this is that number I was saying, and I would much rather write sine 38 than 0.6156647 and just keep going forever. So now that I have sine 38 in, and I know what that number is, my next step is to multiply that by 8. And I'm going to hit equals because I've done everything in my numerator. I have a value for my numerator, and now moving down, I have my division bar next. So I'm going to hit divided by, and again, start with the 50 and then hit sine. And a lot of times this is where students stop and they say, I didn't get the same answer as you, and I'll ask you one more time to hit enter for me. We got a wild answer there. Let me try it on the actual calculator. 38 sine times 8 divided by 50 sine. That's 6.42. So, oh, okay, I see. They haven't actually checked their answer yet. So, for the student who put in 5.4, we may have a calculator issue, and I would imagine it's going to be, oh, okay. I don't want to use your name since I'm putting this on YouTube, but you're in my block 7, and I know that you used the TI-30X2S, the solar edition, the one that we can't use during the EOC. Make sure that when you punch this in on that edition, you have in your display exactly what you see, but you also have 8 times the sine of 38. The directions I gave you guys work with the computer calculator and the TI-30XA. So before you hit submit on that, double check the way you punched in your stuff to the calculator, and we will go on from there. Where is my tool? Now we know that, what does it want us to round to? Nearest tenth, so we have 6.42. So it's going to be 6.4 for side B. I'll put that up here so we don't forget. 1 second. Sorry, excuse me. All right, now let's try and find C. And then let's look at our answers and see if they make sense. Come on. And by do they make sense? Do they just go follow the order? Is my smallest angle opposite my smallest side? And that's just one way, not to mathematically check and make sure it's right, but just that at a minimum, we verified the order makes sense. So now it wants us to find C. So now we know that's going to go on our right hand side. Here's what I want to warn you against. We know this is 38, and we know this is 6.4. This 6.4 is rounded. So if I use this to set up my law of sines, if this is my left-hand side, this is not a precise measurement. This is not the exact length, is really the better way to say that. So you'll notice here it says, do not round until the final answer. And that's because if you round at any point, all those diminishing digits, right, the further away we get from the decimal, they have a smaller impact. But over time, they will build up. So we need to avoid using anything but what we're given when we can. this is 6.4. I'm going to go ahead and draw out my setup. And in my left-hand side, I'm going to do the same thing I did last time. Start with what I was given. This 50 degrees makes a side length of 8. And now I have my unknown and the angle that generated it. So these are going to go over here. That's one of the worst 2s I've ever seen. And now I can do the algebra, cross multiply, and see what I end up with. This is going to give me C times the sine of 50. And that's going to be equal to 8 times the sine of 92. And I want to isolate the C, so I divide by the sine of 50 again. These, of course, cancel. And I'll be left with simply C equals 8 times the sine of 92 over the sine of 50. Now, if we look at our setup here for this equation to solve for C, it looks a lot like our equation to solve for side B. This is another huge benefit of using this approach that I talk about. Always putting the same things on the left side, the 2 known, the ones you're given, the angle on its opposite side, and then putting your 1 known and your 1 unknown on the right will consistently produce answers before you put them in the calculator, right? This is our exact answer. Once we plug this in the calculator, it's going to start rounding because it can't carry all the irrational digits. And we're going to have to accept the fact that we're changing our answer just slightly. But this looks so similar to our last answer. You'll just notice that my angle on my right-hand side changed. So the position didn't change, but that number just replaced the other one. So let's put this in the calculator and see what we actually have here. And then we'll do a quick analysis of whether or not it makes any sense. So here, if I clear this guy out, I'm going to start with my 92. Now I'm going to go to sine. And I have this small number, so I've only done this part. This is 8 times that number, so let me do times 8. And that looks exactly like my numerator, just these two are swapped, and that's okay. We can say 4 times 3 is the same as 3 times 4. So sine of 92 times 8 is the same as 8 times the sine of 92. Verify that I hit equals. I've finished the numerator, so now I can do my division. And then I just have 50 sine. If I press sine, then 50, it's going to take the sine of my numerator again, and that's going to mess us up. And this gives me a new answer of 10.4. So you got this one right. That is rounded. And what we can do now is just double check with our angles and our side lengths. Do these answers make mostly sense, right? What I mean by that is this one was 38, and then this down here is 10.4. Again, like I said in class, we had that problem where we had the triangle on top of the parade float that had like a shark. Oh man, my sharks are just getting worse every time I draw. This is not even a shark. Oh, you know what? We're in for it. We'll stick with it. Let's give it a fin. Okay, so this is our shark. This is our parade float. And in that example, back in topic 6, I believe, we had something like 50, 40, 90-degree angles. So we knew that the 90-degree angle made the largest side. The 40-degree angle being the smallest of the 3 angles gave us the smallest side. And then the 50 being the middle of, in between 40 and 90 would give us the medium side. So here I could say that because angle 40 is the smallest, if I write these in ascending order, side B will be the smallest. Then, since 50 is greater than 40 but less than 90, I would have C next, and then followed by A. Now I can do that same thing here to check my sides, and then if my angles end up falling in the same order, I have pretty good evidence that at least we have a good starting point for these. There's other ways to verify these, but it's really takes longer than you probably will have during your testing time. These are good ones to mark on EOCs or anything where if you have that extra 15 minutes at the end, you've already double checked. These are the ones I would go back, and once you have the law of cosines, verify these. Of course, we don't have the law of cosines until our next class meeting. So here, I'm going to write my angles from in ascending order. So 38 is my smallest, 50 is my medium, and 92 is my largest. And what I'm going to do is I'm going to, underneath each of the angles, write the length of the side opposite of them. This is 6.4, this is 8, and this is 10. Looks like they're in pretty good order to me. And that's actually it. I just didn't plan an ending for this video, and I don't know why it feels like it's ending so abruptly. Let me just say my normal. If you have any questions, throw them in the comments or come to class, ask me about them if you are able to, if you're in my class. Otherwise, let me know if you need anything.